Hello everyone, welcome back to 𝘎𝙬𝙎 classes English YouTube channel. So dear students, as you all know, we are here again with a Pharma 360-degree MCQ series. So this is a series specifically designed for the pharmacist and DI preparations. And in today's video, we are going to discuss about the organic chemistry, and the topic of today's organic chemistry will be addition reactions. In the previous lecture, in the previous video, we have seen the questions, 20 questions from the substitution reactions, and in this question, in this, we are going to see the questions from the addition reactions. So let's get started. The topic of today's class is going to be addition reaction. Let's check it out how much you are having the concepts of the addition reaction. The first question we are having here is, addition reactions are the reactions of. So addition reactions are generally the reactions of, basically, is it the double bonds, single bond, triple bonds, or both A and C, that is double and triple. When we're talking about the addition reactions, we are generally having like, yes, only the reagents are coming and adding to your substrates, and this is only possible when we are having unsaturations in our substrate molecule. So unsaturation, that is basically having of double or triple bonds, then only we are having the possibility for the addition of that reagent to your substrate molecule. So yes, there must be having double and triple bonds, so that one of your pi bond is broken down in such a way like two reagents like electrophilic and nucleophilic reagents are basically adding up. Depending on the case, like which of the reagent is adding first, that describes like which of the following that mechanism is going to be preferred. So we are having double bond and triple bond, so both A and C are right answer, so you can go with the D option. In the single bonds, if we are having just single bonds, so there is no any chance for the addition kind of reactions, but we can do eliminations or substitution reactions. So single will be having elimination kind of reactions. Single bonded molecule can have elimination or substitutions, but if we are having unsaturations like the presence of double or triple bonds, then we can have the reactions of additions, like pi bond is broken down and the reagent is added in such a way like forming two sigma bond. One pi bond break into formation of two new sigma bonds. So yes, both A and C will be the right answer. D is your correct answer. The addition reactions are the reactions of the double or triple bonds. These reactions may be initiated by electrophiles, nucleophiles, or free radical, depending on the case, like which is your attacking reagent. Next, we are having the molecules having carbon-carbon double bond or carbon-carbon triple bond are readily attacked by electrophiles. And if you are having the double or triple bond between two different electronegative atoms, two different atoms, like if we are having carbon double bond with oxygen, that will be having a nucleophilic addition reaction. If you are having carbon triple bonded with nitrogen atom, there is an electronegativity difference, so that will be having a nucleophilic addition reaction. The basic reason is like, look, this carbon and double bond oxygen, carbon triple bond nitrogen. So we know very well, like, yes, we are having two different electronegative atoms. So carbon will be having partial positive charge while the oxygen will be having partial negative charge. And since this carbon, after the breaking of the bond, look, this is carbon, oxygen. So carbon will be getting positive charge. This carbon is having incomplete octet while this oxygen having complete octet. It will be having two lone pairs. So 2, 2, 4, and in this negative charge will be having 2 electrons, so 6 and 2 from this sigma bond of carbon oxygen. So that is, oxygen is having complete octet while this carbon is having incomplete octet, just 6 electron. That's why a nucleophile will be preferred attacking reagent in this kind of addition reactions. Same happening with the carbon triple bond nitrogens. So carbon triple bond nitrogen, due to electronegativity difference, since nitrogen is more electronegative than carbon, there will be a partial polarization of this kind of bond, and when we break the bond in such a way like nitrogen is getting complete negative, carbon is having positive, again carbon is having incomplete octet, while we know very well, like, yes, this will be having again a lone pair on the nitrogen. So 2 to 4 to 6 and to 8 electrons. Nitrogen is having its octet complete, but this carbon is having again incomplete octet. So yes, the carbon double bond oxygen and the carbon triple bond nitrogen will be having nucleophilic addition. Since carbon will be attacked by a nucleophile due to deficiency of electrons, this carbon is actually acting as a electrophile. While in the case of carbon-carbon double or triple bond, there is a electron density ridge centers due to that pi bonds on the same electronegative atoms. That's why such a bonds are attacked by electrophiles or sometimes free radical, depending on the case. If there is the condition, then we can have free radical addition as well on the carbon-carbon double or triple bonds. Next, we are having addition reactions may be initiated by. So addition reactions can be initiated by electrophiles, nucleophiles, free radicals, all of these. So yes, just we have discussed this case. Like yes, these all are attacking reagents. These all are the attacking reagents. So yes, if they all are the attacking reagents, then we can say yes, we can have all of them can be the attacking reagents in your substrate molecule and giving you the kind of reaction. So yes, we are having D as our right answer. D as our right answer. It can be electrophile, nucleophile or free radicals. Molecule having carbon-carbon double bond or carbon-carbon triple bond are readily attacked by carbon-carbon double bond or carbon-carbon triple bond. We know very well, like yes, this is having a high electron center. Like suppose we are having a carbon-carbon sigma bond. If you are talking about the pi bond formation, so this is the pi bond between the carbon-carbon, and we know both of the carbons are having same electronegativities. So yes, this is a high electron density center due to pi electrons, and we know very well, like these pi electrons are loosely you can say overlapped, loosely present, so they can be broken down and can be attacked by a electrophile. Same will be happening with the carbon-carbon triple bond. This is the carbon-carbon sigma bond. Okay, this is carbon-carbon sigma bond, and now in this case we will be having two pi bond formations. So suppose this is our first pi bond formation between the carbon-carbon, so this kind of formation, and the next pi bond formation will be looking like something this. So we will be having this kind of pi bond formation as well. So there will be a perpendicular pi bond formation, since we know pi bond is formed only when we are having p orbitals overlapping. So p can have a dumbbell shape. So yes, this is the triple bond formation, this is the double bond formation. So they can only be attacked by a electrophilic reagent. So yes, A will be the right answer. A can be your correct answer, since there is a strong electrons present just between the both carbon-carbon atoms. Molecules having C double bond or C triple bond nitrogen are readily attacked by, so they will be attacked only by a nucleophilic reagent like Grignard reagent or HCN. These all are nucleophilic kind of reagents. So no electrophilic, they will be only attacked by nucleophilic reagents. B is your right answer. B will be your correct answer. Okay, just we have discussed the case why we are having nucleophilic attack on the carbon nitrogen carbon oxygen bonds. CH2 when attacked with HBr, so this is your substrate molecule. When this substrate is attacked by a reagent, we are getting this addition kind of reaction, that pi bond between the carbon-carbon is broken down in such a way like two of the newer sigma bonds are formed. Now we don't see any condition, any case here present like peroxide, sunlight, nothing. So this will be a pure electrophilic addition kind of reaction. First of all, we will be having H plus and Br minus formation from this HBr. Now this H plus will be attacking first to the double bonded system and making a way for the Br minus to be attacked, and thus we are having a carbocation formation. Then the Br minus will be attacking to that particular carbocation, making it a nucleophilic attack as well. So we are having a complete addition reaction. It's a electrophilic addition reaction. The reason basically here is like H plus will be attacking first. Since the electrophile is attacked, this substrate is attacked by first electrophile. That's why it's named on the basis of that particular electrophile. So yes, we will be having a electrophilic addition reaction. So A will be your right answer. Suppose there is a presence of peroxide, then we will be having a free radical kind of addition reaction. This HBr is only having peroxide effect, and yes, we can have a free radical addition reaction when attacked by a HBr molecule in the presence of peroxide. So A is your right answer. So first of all, we will be having slow step, that is formation of a carbocation after the addition of electrophile. Later on, that nucleophile that is left behind will be attacked to that particular carbocation position. Given structure is addition reaction, find out the products are minor and major. Okay, so there is a major and minor formation. So which will be the major one and which will be the minor one? Okay, so we are having HBr and this is an unsymmetrical alkene. Why we are having this unsymmetrical alkene? Suppose we broke this carbon-carbon double bond here, so we'll be getting CH2, and here we are having a different molecule, completely different molecule. Like CH2 double bond CH2 is a symmetrical alkene. If we broke this molecule, we'll be having CH2, CH2. Suppose we are having CH3, CH double bond CH, CH3. That is also symmetrical. Like if we broke this bond between the carbon, hydrogen, carbon, hydrogen, we are getting CH, CH3, CH, CH3. So that is a symmetrical. But here, if we broke this bond, we will be getting two different parts. So this is an unsymmetrical alkene, and we are attacking it by HBr. There is no any presence of peroxide, so this is a pure electrophilic addition kind of reaction. Now, first of all, this H will be attacked to that double bonded carbon that is having greater number of hydrogen atoms. So suppose we are having H, we are having this CH and CH2. Double bond is present between CH and CH2. So this H will be having partial positive, partial negative, bromine will be having. This H plus will be attacking to that double bonded carbon which is having greater number of hydrogen atoms. So if this is attacking here, what we are going to get? We are going to get CH3, CH, CH3, CH, CH3. This CH2 getting one H plus will be having CH3. Now this H plus was attacking to the position of CH2. It means like the pi bond must be shifted to this CH2, making this carbon electron deficient, means a positive charge CH will be present here. Now, this is a carbocation. Carbocations have tendency for rearrangements. If we are having carbocation formation and if there is possibility to make a better stable carbocation just attached to that particular carbocation, so this positive charge will be shifting to this carbon, while this H minus hydride will be shifted to this position. So once one of the product can be having, just here we are having a attack of this CH3, CH by the Br minus. So we will be getting this. So this will be the minor product. Since there is only a 2-degree carbocation, but there is a possibility of a better stabilized carbocation, that is this hydride shifting, that is a rearrangement. So we will be getting CH3. Now CH, after getting one hydrogen, will be converted into CH2, CH3, and there is a positive charge. And now this carbocation is a 3-degree carbocation. Now this rearrangement will be making a better stable carbocation, and now the bromine can be attacking to that particular carbocation, making a major stable product, since the intermediate was a major stabilized one. So that's why we can say like P is your minor product while Q is your major product. So P is minor, okay, Q is major, okay, major P, minor, so both cannot be minor. A is your right answer. A is your right answer. So this was totally based on the concept of rearrangement of carbocation. Rearrangement of carbocation. So P will be your right answer. Addition of conjugated alkynes reacts with halogen. Which addition obtained at low temperature? So we are having a conjugated alkynes. That is, let's suppose we are having CH2 double bond CH double bond CH2. There is a possibility, like if we are having attacked with halogen acid, let's suppose we are having HCl. So we'll be having H plus and Cl minus. Now this H plus will be attacking to that double bonded carbon which is having greater number of hydrogens. So suppose we are having attacking H here, CH2 and one of the hydrogen, making this CH a negatively charged CH double bond CH2. You can same apply this concept to this CH2 as well. So this is your carbocation formation. And now there are two cases. If the temperature is low, that means there will be no resonance, no conjugation formation, no conjugation will be taking place, and the Cl minus will be attacking to that possible position, making your product CH3, CHCl, CH double bond CH2 at low temperature. But this is thermodynamically less stabilized product. You can have a better product formation, suppose at 40 degree centigrade, 40 degree temperature. If you apply 40 degree temperature, this carbocation move to that position due to conjugation. Since there is a conjugation process possible here, condition is present here. Now that Cl will be attacking to this positive charged position, making CH2, sorry, CH3, CH, double bond CH, CH2, Cl, CH2Cl. We are having alkene as our product. Here also we are having alkene, here also we are having an alkene. Alkene that is having greater number of alpha hydrogens is more stabilized. Thermodynamically, this product is more stable. Since this is your alkene, and now alkene are stabilized by presence of alpha hydrogens. We are having 2 alpha hydrogens present here, 3 alpha hydrogens present here. Total 5 alpha hydrogens, but here we are having, this is our alkene, we are having just alpha carbon here and just 1 alpha hydrogen. Better the number of alpha hydrogens, more will be that particular alkene's stability. So in this case, at low temperature, we are having just 1,2 addition. But if the temperature was high, then we can have 1,4 kind of addition, and that will be giving you a thermodynamically more stable product. So this will be having just 1,2 addition. 1,2 addition, okay? 1,2 addition product. 1,2 addition product. So addition reaction, conjugated alkynes like buta-1,3-diene react with halogen acid, hydrogen and water, acid yield mixture of 1,2 and 1,4 addition products. Low temperature is favoring 1,2 addition, while at higher temperature we are getting 1,4 addition, that is more stabilized one. That is more stable product. Following statements is correct about electrophilic addition reaction. Plus I group increases the rate of addition reaction. Okay. So this plus I group is actually having electron donating tendencies that will be stabilizing that particular carbocation. So yes, making it better stable carbocation. So more stable rate of reaction. Minus I group decreases the rate of reaction of addition. Correct. Very true. Minus I are electron withdrawing groups. So they actually withdraws the electron density from the carbocation, making it more unstable. So that is also true. Plus M stabilizes carbocation. Same. Plus M are electron donating groups. They actually donate electrons towards that particular carbocation, making it more stabilized. So yes, that is also true. Minus M stabilizes carbocation. No. They destabilizes. They destabilizes carbocation. Thus, you are having 1, 2, 3 as the right answers. 1, 2, 3 are correct, but 4th is wrong. 1, 2, 3 is true. 1, 2, 3 is true. Okay. So yes, plus I increases the rate of addition reaction, true. Minus I decreases the rate of reaction. Plus M stabilizes the carbocation, thus making better stable product. Minus M destabilizes. So that was false. Here we are having stabilizes. So no, that is destabilizing. So that is also a wrong statement. When ethene reacts with bromine, we are having ethene, that is CH2, double bond CH2. We are attacking it with bromine. What is the product form? So we are having product formation like we are having CH2Br and CH2Br. So this is your addition product, that is ethene dibromide. No, that is not ethene now. That is not ethene. This is ethylene. This is ethylene group, and we are having 2 bromine groups. So ethylene dibromide, yes. That can be right answer. Ethylene bromide, no. Ethylene dibromide, we are having 2 bromines. So ethene bromide, no. So we are having B as our right answer. B is our right answer. That is 1,2-dibromoethane or ethylene dibromide simply. The reaction of Grignard reagent with aldehyde and ketones give alcohol. This is known as. So we are having aldehydes or ketone that is having carbonyl group, that is C double bond group. That will be a nucleophilic kind of addition reaction. Nucleophilic addition, not substitution, that is not electrophilic addition. So that is nucleophilic addition reaction. A is your right answer. Formaldehyde will be giving you HCHO will be giving you 1 degree alcohol. Aldehydes will be giving you, aldehyde except formaldehyde will be having 2 degree alcohol, secondary alcohol, while ketones, after ketones will be giving you 3 degree alcohols. 3 degree alcohols. Okay, so formaldehyde just primary alcohol. Aldehydes will be giving you secondary alcohol, while this ketone will be giving you tertiary alcohol. Following reaction X is, so we are having carbonyl compound and HCN. So this is C double bond O. So suppose this can also be written like something, this CH3 C double bond O CH3. we are having HCN, that is CN minus. There will be there is something this kind of CN and CH3, and now after hydrolysis we will be getting CH3 COH, cyanohydrin complex formation. So carbon will be having two methyl groups, one CN and one OH group. So we are having carbon with two methyls, okay, one OH, yes, one CN. So this is correct. That was having NC and no OH group, that will be wrong. No NH2, CH3 CN, no OH. So only A is your right answer. Cyanohydrin complex formation will be happening here. We will be getting a cyanohydrin structure. Which of the following is a final product in reaction of HBr with propene in the presence of peroxide? So we are having peroxide in this case. We will be reacting HBr with propene, that is an unsymmetrical alkene. CH3 CH double bond CH2. When we react this with HBr in presence of peroxide, we will be getting a anti-Markovnikov addition product. So that will be having this H will be adding to that double bonded carbon that is having lesser number of hydrogens, lesser number. Till electrophilic we have studied, this H will be adding to that double bonded carbon that is having greater number of hydrogens. But for the free radical, now this presence of peroxide is actually telling us like this reaction is having a free radical addition kind of mechanism. So this H will be attacking to the carbon that is having lower number of hydrogens, and the bromine will be attacking here. So we'll be getting CH3 CHH and CH2Br. That can also be named as 1-bromopropane. So 3-bromopropane, no possible. Allyl bromide, not at all possible. N-propyl bromide, yes, that can be correct. This is the common name. N-propyl bromide. Isopropyl, no. That is N-propyl bromide. So C is your right answer. That is actually having a anti-Markovnikov addition reaction or peroxide effect, or that can also be sometimes named as 𝙎𝙎 effect. The addition of HBr is easiest with. So HBr can be added easily here. CH2CHCl will be having here addition. No, this is having a minus I group. We are having two minus I groups. We are having one plus I group, and here we are having two plus I groups. So better the plus I groups, more stable this addition can be happening. So D is the right answer due to 2 plus I, 2 alkyl groups directly attached with the double bonded carbons. Okay, double bonded carbons making a better stable carbocation intermediate, and the better stable carbocation intermediate, that means faster the rate of reaction. What is the main product of the reaction between 2-methyl propene with HBr? We are having 2-methyl propene. 2-methyl propene. Okay, propene we are having here. Now we are reacting this with HBr. There is no any presence of peroxide. Okay, so this will be a pure electrophilic addition reaction. Now this H will be adding to that double bonded carbon that is having greater number of hydrogen due to electrophilic addition reaction. And this is the rule by Markovnikov. So we'll be getting CH3 C CH3 CH, directly write down 3 2 and positive. Now this Br will be attacking and giving you CH3 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 and bromine. So that is 2-bromo 2-methyl propane, 2-bromo 2-methyl propane, 2-bromo 2-methyl propane, 2-bromo 2-methyl propane. Yes, D is your right answer. D is your right answer. Better stable carbocations. Okay, better stabilized carbocation. In which of the following 𝙎𝙎 effect operates? 𝙎𝙎 effect, that means anti-Markovnikov addition. Anti-Markovnikov's addition, that means free radical addition reaction. That means peroxide effect. That means unsymmetrical alkene. So that is only possible, let me write down one more thing, that is only possible when HBr is added in the presence of peroxide. peroxide. HBr in presence of peroxide. So HCl is wrong. HBr, HI is wrong. Now we are having HBr here, but this is symmetrical alkene. Look, CH3, CH3. So this was symmetrical. This is a symmetrical alkene. So that is not possible here, here. So left is unsymmetrical alkene, CH2, CH3, and reacting with HBr. And yes, we are having Ḥ effect. So yes, it means the presence of peroxide. So B is your right answer. B will be your right answer. B will be your right answer. The general order of reactivity of carbonyl compounds for nucleophilic addition reactions is, so formaldehyde highest reactive due to, like suppose we are having carbon double bond O. If we are having this positive charge on carbon, the attacking groups or the substituents that are actually directly connected with this carbon, if they are having plus I groups, they are having electron donating natures, they will be stabilizing this partial positive charge. So the formaldehyde do not have any kind of alkyl groups, do not having any plus I groups, so they will be having the least stability of particular polarized carbon. That means yes, that will be most reactive one. So wrong, yes, that can be true, or this can be the right answer. Next we'll be having the 1 degree aldehydes, and here we are having ketones. No, here we are having 2 alkyl groups that are 2 plus I groups, that is more stabilizing that particular positively polarized carbon, but this is having just 1 alkyl group, so this cannot be true. This, then we are having aromatic one, then we are having 2 alkyl groups, then the 2 aromatic groups. So yes, A will be the right answer. A will be the right answer. A will be the right answer due to better stability of that particular partially polarized carbocation that is actually here present in the form of electrophile. The intermediate in the electrophilic addition reaction is, so in the electrophilic addition reaction, the intermediate is, when we are having electrophilic addition reaction, then we will be having a carbocation intermediate, carbocation, no carbon ion, free radical, that is free radical addition reaction. So carbocation will be your right answer. In Ḥ effect reaction follows. In Ḥ effect, what reaction follows? Free radical substitution? No. It will be following free radical but addition reaction. Electrophilic addition? No. Free radical addition? Yes. C is the right answer. C is the correct answer. Free radical addition reaction. What type of reaction takes place upon treatment of a ketone with HCN to form a cyanohydrin? So that will be having a carbonyl compound, HCN, a nucleophilic kind of addition reaction. Nucleophilic addition reaction, no. A is the right answer. A will be your right answer. Which of the following products is formed when benzaldehyde is treated with CH3-MgBr and the addition product so obtained is subjected to hydrolysis? So we are having a benzaldehyde molecule, C double bond OH. We reacted with CH3-MgBr. So this will be like something, this formation CH3 minus and MgBr plus. This will be attacking to this positively polarized carbon. Okay, positively polarized carbon, and now this pi bond between carbon and oxygen will be shifting to the oxygen, making we are having first C. So we are having C, that will be having a O minus MgBr plus once here, and now we are having a hydrogen and we are having a CH3 group. We will be having a CH3 group attached here. So this is your you can say addition intermediate kind of reaction. Now acid hydrolysis, upon acid hydrolysis we will be having this MgBr removed and a new OH will be added. New OH like CH, CH3 and OH. This will be your product formation after the acid hydrolysis. So we will be, what we have got, a secondary alcohol, primary alcohol, phenol or tertiary butyl alcohol. So we will be getting a we will be getting a secondary alcohol. Why? This carbon is attached here with carbon and here carbon. So we are getting a secondary alcohol, that is A as our right answer. A as our right answer, that is 2-degree alcohol. So this is the questions of addition reactions that we have seen in today's video. I hope you all enjoyed the questions and answered them. Now we'll be again connecting with you all with some other topics. Thank you so much for joining with us. Keep connecting with us, and every day we are getting some of the newer videos with all the subjects of your pharmacy, in which we are getting the questions of that particular topics of each subject with detailed explanation with the expert faculties. I hope you enjoyed this series, and this series will be beneficial to you all. Thank you so much.